Okay, now we will draw the shear force diagram, bending moment diagram, and axial force diagram of this beam. So let me draw the beam. There is a concentrated load 15 kip. The angle here is 60. There is a concentrated moment kip feet, and then after some time there is some uniformly distributed load. So this is 7 feet, this is 5 feet, this is also 5 feet, this is 5 feet. Okay, so we got our question. Now we will 7555. Oh, this value 6 kip per feet. Everything else I took it. Okay, so what is step number 1 for finding reaction? See, if I write it down here again, I am writing again because it is important. If you follow the steps, it's very easy. So step number 1 is finding all the reaction. Step number 2, follow loads for shear force diagram. Step number 3, oh, I forgot the normal force diagram. I will, okay, do it. Step number 4, sum up area of shear force diagram for moment. Then it's number 4, or maybe it can go here also. Uh, axial compressive, axial compression, or axial tension. Just show it simply. Okay, so what to do is number 1 is to find reaction. What's my reaction? Say one force here is say A. Say this here it is A X. Here it is B. This time I am not writing B Y A Y because it's clear AX and A B. Make it simple. There is no standard way to write it. It's up to you. Okay, so how to find? Okay, what do we do at the beginning? We try to find AX because it is very easy. Whatever easy, do it first. Summation of force along X direction is 0. Say clockwise is positive. Oh, my video is on, so I do not need to turn on all the lights. Oh, so summation of force along X direction is 0. What is my force? AX. AX is left side. AX. Then what is the other force along X direction? Is 15. It is inclined. It has two components. One is vertical, one is horizontal this way. So we need horizontal, that is positive because right side or right way. 15 cosine 60. No other force, so 0. Then what is AX? AX is 7.5. How do I know 7.5? Last class we memorized this. Cosine 60 means 0.5. Even I memorized it uh, as I did many times. So cosine 60 is 0.5. Sine 30 is also 0.5. Cosine 0 is 1. Cosine 90 is 0. Sine 0 is 0. Sine 90 is 1. So these are some common values that we commonly memorize. You do not need to memorize, just use calculator. Okay, so we got X. Now we will find B. How to find B? So summation of moment at A is 0. Say clockwise moment positive. What is the first load? First load is 15. Sine 60. Distance is 7. Question is why sine 60? Why not cosine? Because cosine is horizontal component. Is going through this point, so it will not give any moment. The vertical component will give moment. Okay, so we got it. Positive or negative. So this will give me clockwise moment. Okay, next one. 50 kip per feet. Will we consider it? Yes. Why? Because we are summing up the moment, and that is a moment. So we will consider it. Next question, is it positive or negative? You can see here, I assume clockwise positive. So that is clockwise. So I will add it positive. Keep feet. Next load is 6 kip per feet. It is uniformly distributed load. So we can consider it at the middle. 6 times 5 is 30 kip, where it will act at the middle of this 2.5. Okay, so positive 30. What is the distance? 7, 5, 12, 5, 17, 19.5. I know that if I give you this problem to solve it now, you will get lost. But I do not know why. Just follow the procedure. Nothing to think about. No, no like rocket science. Nothing. Simple mathematics. Sum up. Okay. Then what is my next load? B. That will give me counterclockwise moment. So minus. So minus B. What is the distance? Distance 7, 5, 5, 10, 17, 17 plus 5 is 22 feet equals 0. I know that to many students, this part is the most difficult part to take a moment at some point. But why? Take some more point, then force time distance, force time distance, force time distance. Nothing too scary. If you make your, if you want to solve it, you can solve it. Okay, then if I do the calculation, 15 times sine 60 times 7, or something else to tell you clearly, 50 kip per feet. You see, I did not multiply the distance here. I did not multiply the 12, 12 feet distance. Why I did not multiply? This is already a moment. You should not multiply moment times a distance. So again, if it is a concentrated moment, do not multiply the distance. 50 plus 30 times 19.5. I got 33. So I got B equals 33. 32.99. So I will take 33. I got a positive number. So my direction is right. It's upward. AX was left side because it is positive. When you solve it, if you can feel the problem, feel means like you get the feelings, what is happening, then you will get the test. Otherwise, it is just mathematics. Okay, then I have to find A. How to find A? Change the color. Summation of force along Y is 0. Say upward force is positive. What is my first force? First force is A. Next one is 15 sine 60. Next question, will I consider 50 kip feet? Answer is no. Now why no? Because I am summing up the force. I will not consider the moment. When I will count the goat, I will not count the sheep. So inside goats, if there is a sheep, no problem. When I will count goat, I will just count goat, no sheep. So 50 keep feet is a moment. I am considering the force. So I will not consider. Still I am writing here to confuse you. Do not consider this. Yes. Then next is 30 keep. 30 keep feet is down and plus next is B. B is upward. What is the value of B? 33. You can write B or simply write 33 equals 0. Do not consider this 50. What is the value of A? If I use calculator, 30, 15 times sine I got 9.99. I will write 10. So you can see I am rounding up 9.99. I wrote 10. So in the diagram there might be small rounding of error, but that is okay. Okay, so we found the reaction. Hopefully you understood how I found it. And something to remember in this problem, some specialty in this problem is there is a concentrated moment. And when we took the moment, we consider it, but we did not multiply the distance. That is a new knowledge. And then when we took summation of Fy, we did not consider this 50 because we are taking only force. We will not consider 50. That are the two new knowledge we found in this problem. In fact, that is why I was looking for a problem with concentrated moment. Okay, now I will draw the diagram. So I will go to next slide. Make sure you took it down. Okay, wait few more seconds. Okay, hopefully you took it down. Now draw the beam again. It is easy. This was 10. There was 15 here. This way I think. Or this way or the opposite way. Let me see. Opposite way. See, my memory is very dull now. COVID killed me. So this way is 15. 60 here. Then there's a concentrated moment here is 50. Then there are some uniformly distributed load. Then finally it was 33. Keep. Distance wise it was 7. This was 5. This was 8. This was 5. This is 6 kip per feet. Okay, so we will start diagram. First we will draw say axial force diagram. Oh, something here. Here I had 7.5. Okay, so let us first draw the axial force diagram. Normal force diagram. NFD, normal force diagram. Now the simple way is to find the area inside the beam which has axial tension or compression. At the beginning there is a load here. You can see this beam, this load is pulling this beam, pulling this beam. That means pulling, that means tension. So it is up, up. And then there's nothing here, here, nothing here. So I will keep it the same thing, same thing. So that means this portion is pulling me left. After coming here, I find that there's some component here that is 7.5 this way, then it will come to 0. Why it will come to 0? This AX 7.5 left, this 7.5 is right. So after it is balancing or cancel out each other. After that there is no other load. And is this portion positive or negative? Positive, because this force is a pulling this portion of the beam. After this there is no other load. So this is the normal force diagram. What is the value? Write down the value 7.5. Keep. Something else. Normal force is not common in beam. Is very uncommon. So most of the time you will see in your FE exam or even in PE exam, you will see question from shear force diagram, bending moment diagram. Normal force is rarely asked. It's not so important or not so common. Okay, then I will draw shear force diagram. How to draw? Follow the loads. Okay, how to follow? What is my initial load? 10 is up. Okay, go up. Where is my mouse? So 10 keep up means positive. Okay, I went up. After that I have no other force, so keep as it is. After coming here I saw that I have a load which is vertically downward, which is 15 sine 60. What is the value of 15 sine 60? 15 times sine 60. It is 12.99. Oh, this is how my fraction is coming. So I need to go 12.99 down. So if I go 12.99, I'll come actually here minus 3. 12.99, I'm considering 13. So I had 10, I will minus 13, I'll come to minus 3. Okay, so delete it because 13, because this 13 actually is not our value. I'm just showing you. Okay, then I will keep as it is, nothing else. There is a concentrated moment here. Do I need to do anything here? No. Again, why no? Because I am considering the force. I will not consider the moment. That is something to remember. I am considering the force here, shear force. So no moment. We will not consider moment. So we will not look at the moment. After coming here, yes, I have something to do. After coming here, there is a load which is telling go down 6 kip per feet. After going 5 feet, I have to go down how much? 5 times 6, 30. So I will go linearly. I had minus 3. I will reach to 33. Why? Minus 3 minus 30 is minus 33. Now, is it linear or no? Linear, because this load is uniform. So I will go down uniform. Or whatever the value here, value, value, that is the slope here. Now, how it is true? Value here is negative and constant. Slope here is negative and constant. So this is the other way you can remember. Okay, after coming here, this load is telling me jump by 33. 33 jump, then come to 0. So you can see my diagram is a closed loop. That means my diagram is correct. If you find some value, if it is very small fraction, that means it's a rounding error. So that is okay. But if you find a big value, that means somewhere a problem, go back and check. Okay, then make it beautiful. This portion is linear, all about minus 3. Give a plus sign here, minus sign here, minus sign here, so that you can see clearly. Okay, shear force diagram is done. We'll go to moment diagram. And what is the next step for moment diagram? Change the color. Okay. So these are my points, some critical points. Okay. So what for moment diagram? What are the steps? Sum up the area of shear force diagram. At the beginning, what is my moment? 0. Why 0? That was a pin support. Pin support cannot take any moment, so 0. Then up to what is my area of this portion? 10 times 7, 70. So when I will come here, my value is 70. Positive or negative? Positive, because this shear force is positive. So I will come somewhere here, 70 kp. So or simply write here bending moment diagram, unit is kip times feet. Shear force diagram, unit is kip. Normal force diagram, unit is kip. If you write down the unit here, you do not need to write the unit here. Make it clean. Everybody of us like to be clean, but we do not want to clean. That is the problem. Okay, so it is 70. Then now how I will go? Straight line or concave up or concave down? Straight line, because my value here is positive constant. Slope here will be positive constant. That is one way. Second way is it is my area is increasing proportionally, so I will go proportionally. This is two way. Third way is whatever the value here, that is a slope here, you can use the calculus equation. But I know that by this time you already memorized it. That If it is uniform, my slope will be uniform. Okay, then after this portion, what is my area? Minus 3 and times 5 feet. So minus 15 feet. So I had 17. If I do minus 15, it will be, oh, my brain is so dull. 70 minus 15 is 55. Okay, so I'll come here 55. How I will come here? Straight line? Uh, yes, straight line. How is why straight line? Because the area here is uniform, so that will be a, okay. Okay, I cleaned it a little bit. So this will be 50. Oh, again I made a mistake. I should not write it here. I should write it somewhere here. 55. And this line is a straight line because the value here is minus constant. Slope here will be minus constant. Minus means negative. Okay, after coming here, what to do? You can see I had a concentrated moment. I need to take care of this. Why? Because now I am considering moment, so I should consider the moment. It is 50, and sign convention, you can remember, inside beam, uh, clockwise means positive. So something to remember, for when draw the moment diagram, clockwise moment is positive. Clockwise movement is positive, so remember this. So there will be a jump will be how much? 55 jump. So total will be 105, and that will be positive. Why positive? Because it is a clockwise movement, positive. So there's a jump. That is something to remember. Next, what is the next step? Next step is I will change my color. Okay, then this area, how much this area? Minus 15. Why minus 15? Because it's minus 3 and 5 feet. So minus 15. So I'll come gradually to here, uh, and that will be 90. That will be 90. Then I will come here to the end. At the end, moment is 0. How do I know? It was a roller support. If you can remember, there's a roller support here. Roller support. So moment here is 0. So the area of this portion will be 90. Okay, let us see how it is 90. What is the area? That is trapezium. Okay, let me draw here. So this portion is 3, that portion is 33. So minus 33 minus 3, and the length is 5. So what is the average height? 33 divided by 2. That is the average height. What is the distance? 5 feet. So 36, 8, that means 18 times 5. 5 times 18 is minus 90. What is my value here? 90. Minus 90 is 0. So we got the answer. Yes, it is true, and we are on the right path. Question is, how I will go here? Straight line, concave down, concave up. Common sense, what I am applying. Less value is here, more value is here. So I will decrease slowly at the beginning and jump at the end. That means it will be this one, this shape. Now not this the bottom one, because this one means many value is here and less is here, but case is opposite. Or something else, this value is negative and negative increasing, this value negative increasing. So my slope here will be negative, and my negative slope is increasing. You can see that way also. Okay, it looked that we did very extraordinary work today by solving this problem. This problem has so many things to do. Okay, now check what to do. Oh, is my diagram right or wrong? You obviously right, because we came up with a 0 value. That means it's right. Something to learn in this diagram is If there is a concentrated moment, do not consider it in your shear force diagram. And third thing you can check, we know that moment is maximum where there is a change in direction, change in sign of the shear force. Where the shear force changing sign, it is here. But you can see my moment here, yes, my moment here jumped, but it could not win because of this concentrated moment. So that is something unusual. In fact, this is why I tried to solve this problem. So if there is a concentrated load, there are some changes, some twist. So make sure you pay this attention. What else? Okay, nothing else. It's very simple. So I will stop my video here.